Okay, take out your notes. On your notes, the top. Today is March, what do we have, 4th? March 4th. 3-4 of 10. Not, okay, fine, not tomorrow. The quiz is actually on Monday. So this is your last day of review for the quiz. Now this person posted their artwork on YouTube, or on, I don't know where it was exactly, but I got it off Google. And this is considered a recursion when it comes to art. Now I'm not sure exactly why, but it seemed like he's pretty smart, so he's probably got a reason. So anyway, I didn't know what, I had a nice picture for almost every other page. So anyway, there's even recursive art. So let's talk about everything you could say about 1, 2, 4, 8. A sequence like that, first of all, it's a sequence. Second of all, what kind of sequence is it? It's geometric. Why? Because you're multiplying each one to get the next one. All right. So it's a geometric because of multiplication. If it had been adding, what would it be called? Arithmetic. These are all things you should know about your math so that when you take the quiz, you'll be all right. All right, now we can write an equation for this, and I'm going to ask you to write this recursive equation starting with u sub 1 as your first term. Go ahead and write it down right now. U sub 1 equals 1, and go from there. I'll pause what you do. Okay, here we go. U sub 1 equals 1. U sub n, given by u sub n minus 1. And then we are multiplying each time by 2, right? Now, I can write a 2 in there, or I could say 1 plus 1. Here's why I'd recommend writing 1 plus 1. First of all, when you do the big equations later, whenever you're multiplying, you're going to use 1 plus a rate, and then the rate is going to get divided by something, but you can't like put it all together and divide it by something. So bottom line is, this is better because it'll work later, and also because if I asked you, and you just put a 2 here, and I asked you how much bigger it's getting, you'd probably think it was 200% bigger. That'd be a very easy mistake to make. It's not 200% bigger. You can tell how much bigger it is by saying, well, when you times it by 1, you just get the same thing back again, right? So the part over here is the growth. Now can you see that it's actually 100% growth when you multiply by 2? You get that? Because if I just times something by 100%, it stays the same, right? It doesn't grow. So if I have the number 8 and I multiply by 100%, I still have 8. So if I want it to grow like twice as big, then I multiply it by 200%, then it's not growing. You can't say that it has a growth rate of 200%. The growth part is this part, and that's a growth of 100%. So that's 100% growth. Okay, so this represents 100% growth. All right, moving on. This one, 1, 2, 3. Back when you were learning your 1, 2, 3s and your ABCs, the teacher could have blown you away by writing out what you can do right now. Sort of fried your little first grade brain. What can you write? How do you start? U sub 1 equals 1. U sub is equal to, and then what? Where? Yep. Same thing though. Same thing as the, add 1 each time. It's just a different way to say it. Okay. Now, I want you to think for a second. If you use your calculator if you want to, and find me the 500th term. What is it? 500. Okay, it's kind of cheating. But you'll need your calculator for the next one. What if I used u sub 0 to start this? The 500th term would still be 500, but it wouldn't be u sub 500. See what I mean? Let's keep it simpler and just talk about the third term. Okay? What is the third term? It's simple. There's only one third term. What is it? 3. But if I start with u sub 0, this is u sub 1, and this is u sub 2. So if I ask for the third term, you really should look for u sub 2. You see how that's confusing? So when you're just asking for a term, it's best if you use u sub 1. But when you're doing a real world problem, like about vampires, you might want to use 0. There are vampires. They're just vampire bats. The vampire bat likes to land on the back of a cow, usually not on a human. Could be a human, though. The cow is just standing there asleep because they sleep standing up. And this thing lands on its back. I'm sure it's very light, probably doesn't even notice it. And then it doesn't bite with the big teeth. It uses its tongue. And it makes a little incision in the cow's neck or wherever. And then it just kind of laps up the blood that comes out. And so there are vampire bats. There really are. All right. Let's say that Count Dracula has been counting his bat collection. And in 2006, he had 650. And it looks like some sort of bat flu is going around because he's got less the next year and less the year after that. Would you please put this into your calculator and figure out for me how many bats he'll have by the time you graduate in 2013? I'll pause while you set that up. Some of you probably are smart enough to know this, but the 2006 thing, you can put that in your calculator right here and make it your first term. That's the smartest way to do this. That way when you read your chart, you just can see right away, oh, your 2006 is this, your 2007 is that, etc. Okay. Now, I've got one on my formula here. I've got 1 minus 12. Do I have that right? Is it 12% decay? Was it 12%? How'd you get that? 572 divided by 650. Okay. So that's how you got that. And next we go to the 400. Is that right? No. What should that be? 650. 6, 5, 0. Okay. And then I go to table settings to make sure I'm going to the right spot. I can go in the year 2013. That's good. That's where I should go. And then I go to calculate. No, I don't really need that. I could have done that could have done a different way and done that. And there it is. So you get 265 bats, or 266. Raise your hand if you got that. Okay, good. And you're looking like you know what you're doing. That's good. All right, let's try another one. Just tweak it a little bit. Use the same type of a formula. This is a real world situation. Health insurance, for me, when I started, it was like, I don't remember the number, but it was really pretty cheap to add your family on for health insurance. I had to pay an extra like $100 a month or so. And after that, it increased a lot. I'm just going to tell you, it was about 11% increase over that time. And now I'm still teaching, but it's 2010, long time later. And what's the total that it should cost if it was really 11%? All right, well, I put that into my calculator here. I go to y equals, I start with 1992, and then I go, I want 11% increase, so I go down here and make it 0.11, and then I go down here and say I want this to start at 125 bucks a month. Oh, sorry, you're right, I'm making costs go down. Costs almost never go down. Yeah, it would be nice, but it isn't. Okay, and then I hit enter, and then it should be good. Then I look up at my table settings to see where I'm starting, and let's just go to the year 2010 right off the bat, and I go to enter there. Uh-oh, I didn't mean that. Clear that. You know, it actually would make more sense to start in 1992 just to make sure that my graph is looking right, or my chart's looking right. So it starts with 125, just like I wanted it to. And then I can use the arrow key to go down. It'd probably be faster to do it a different way, but there we go. 2010, $817 a month to add your family on, and that's pretty close. That's pretty close to what I pay per month to add my family to the plan. It's kind of expensive. That's a lot of money. 800 bucks a month is like what I paid in for my house. So it's not quite that much, but you get the idea.